So far we were discussing on electricity, correct? Yes. So electricity na enna paathu namme basic ah the rate of flow of charges, and that will happen when there is some potential difference across the circuit, correct? And we had some law also for that. We call them as Ohm's law. V is proportional to I, V is equal to I into R, where R is going to be constant and it is otherwise called as resistance of the circuit, correct? And also we were discussing on combination of resistance, all those stuffs, right? So now what we are going to do is, okay, what is going to be the effect of this current? Right? So we had a potential difference across the conductor and there were flow of charges. Okay, what happens if a flow of charge is there? Or what happens if the charge flows? So that is what is this chapter. Okay, so this is nothing but magnetic effects of current. Okay, so Hans Christian Ørsted is a scientist. In the late years, what he found is when there is a flow of charge in a conductor, there is going to be magnetic field around it. Okay, there is going to be magnetic field around it. So how he actually concluded that? So he was just experimenting with respect to a conductor and there was a compass behind it. So when he passed some current, there were some deflections in that compass, and then he started his investigation. And he came into a conclusion by proving it experimentally as when there is a current flow in a conductor, there is going to be a magnetic field around it. Okay, and also he proved that the magnetic field around the conductor is going to be in circular form. We normally have circular concentric circles inside. Okay, so and also he proved that the magnetic field which is going to be produced because of electric current is going to change its direction. So basically it should be rotating. Okay, so that is how he defined it. And later on there were some more scientists who investigated very deeply and gave them the empirical relation. We normally call them as mathematical formula for finding out how much amount of magnetic field is going to be derived for the flow of charges. So but it is out of scope for you. So in this chapter you don't have any formulas and all, but you will know how a magnetic field works and how a current is going to give you a magnetic field. So before knowing what is a magnet, what is the effects of electric current, so we will just know what is a magnet. What are their properties? Because without knowing the magnetic field, you cannot say that the current is going to be passed in a conductor and you are going to have a magnetic field. If you are not aware of magnetic field, we cannot speak on that, correct? So we have to know what is a magnet and what are magnetic field and how are they are going to be classified and what are their properties. And then only we can go in deep with the electric current effect. Is that clear? Okay. So now first, what is a magnet? What is a magnet? Attracts to metal. Is that so? Iron attract பண்ணதா இல்ல மெட்டலுக்கு எல்லாத்துக்கும் attract பண்ணதா? Iron attract பண்ணது. Okay, so let us say like attracts iron pieces. Okay, அடுத்து has north pole and south pole. Okay,
attract to opposite.
They are all properties. I am asking what is a magnet. I am not asking what a magnet does. Okay, you told that it attracts iron pieces. Okay, right? Yes, and then okay, so it is going to be like the strength of the magnetic field is going to depend on the distance in ring. Okay, right. Anyways, see, basically a magnet attracts iron pieces, correct? Or otherwise the magnetic materials basically. Okay, so we have two types of magnets. Okay, so one is going to be natural magnets and the other one is ஒன்று நேச்சுரலாகவே இருந்தால் இன்னொன்று என்னவா இருக்கணும்? Yes. So natural magnets, we know pretty well. What is natural? Which comes naturally. Okay, so it's not man-made. By nature we get that. Okay, say for example magnetite அப்படிங்கிறது, it is nothing but an ore of a magnet where we will be extracting magnets from the magnetite ore. Okay, so they are always going to be extracted from a ore called as magnetite ore, right? And also they are going to be always weak. They're always weak, and you cannot make it into different shapes. Right? So these are all the drawbacks of natural magnets. But what are artificial magnets? It is basically man-made, right? It's going to be strong, and you can make it into shapes. Basically make it into shapes என்றது வந்து cannot make it into shapes, okay, and make it into, it's going to be strong, it can be made into different shapes. Okay, how these artificial magnets are being derived? Okay, what are the different types of shapes which we can have it? So you can have like disc shape, ring shape, bar shape, horseshoe, and etc. Right? So there are different types of shapes that can be made by using this artificial magnets. Say for example, you have a magnet here. Okay, it is nothing but it is made up of almost magnetic material, right? So basically artificial magnets, how we can make is, you have to stress it with magnetic field constantly. What type of material will make it is mostly ferromagnetic materials. So ferromagnetic materials are nothing but strong magnetic materials which can be converted into magnets by subjecting it with some strong magnetic field. So when you are placing this iron piece, say for example, or a normal any other magnetic ferromagnetic material in a magnetic field, and if you are stressing it on with that, what will happen is at certain point it will start to magnetize. What it means is magnetic materials, basically it will get attracted by the magnets, but when you are stressing it constantly with respect to some high magnetic field, it turns out to be a magnet. Okay, so you have a magnet here, it's nothing but a bar magnet, it is an artificial type of magnet, and you can see a dot here, right? So this dot is going to be defining it as north pole. Okay, right? So whether it is magnet or not, how can I find? Okay, attracts to a iron piece basically. Okay, so I have an iron rod here. Okay, so when I bring this here, you can see the attraction. Yes, right? So it has been attracting, but it's not as strong. Okay, so it is somewhat weak. Okay, so this is going to be attracting, right? Okay, so this is magnet, and also you can find whether it is a magnet or not by bringing it near with the compass. Yes, so I told you this is going to be north pole, so I bring this here. So can you see the deflection? Yes. Okay, if I rotate this, automatically this is also rotating. Yes. So see here, I have placed it in this direction. Can you see that? Yes. So if I am rotating this, this also turns, the compass needle turns, yes or no? Yes. So it is because of attraction of magnetic field, and also there is a needle inside which points the direction, that is also magnetic in nature. So these two are magnets, right? So you have a north pole and you have a north pole. When I am bringing this, it ripples, right? So like poles ripple, and suppose if I am turning this, and you can see there is attraction. Yes, so they are going to be unlike poles. So unlike poles attract, and like poles ripple. The same case for south. If I am bringing two souths nearer, it will not attract, it will ripple, right? Suppose if I bring a north and the south, it just attracts. Is that clear? So this is called as attractive property of the magnet. Okay, and also there is something called as directive property. Suppose if I tie this with a rope or a thread, and if I am suspending it, so it automatically turns towards north and south of earth. Okay, because earth is considered to be a massive magnet. Okay, there are some myths behind it, but it is unfound that how the earth is considered to be a magnet yet. Okay, but still it attracts towards the magnets. So when you are suspending this with a thread, Okay, so it automatically, when you are suspending it with the thread and if you are lifting it, it turns to the direction of north and south. Okay, so basically this is nothing but called as directive property of a magnet. So we have two properties. So the magnets are going to be attractive towards either the opposite poles or the magnetic materials. Okay, and they are going to be having directive property where it represents the direction of magnetic north and south poles when it is suspended with the thread. Okay, and like poles repel, unlike poles attract. Right? So these are the basic properties of magnets. Is that clear? Right? So these are the basic possible. And also you have one more thing. Magnetic monopoles doesn't exist. Suppose if I am cutting this magnet, bar magnet, into pieces, okay, can I take this south pole alone? No. So when you are cutting the magnets also, the magnet will have north and south. So magnetic monopoles are not possible, they are always dipoles. Dipoles means two poles. Okay, yes, so north pole and south pole is always going to be there. Even if you cut it or smash it, you are going to have two poles. Okay, so magnetic monopoles doesn't exist. Can you see the north pole, that dot? Yes, so this is nothing but north. Amava, இது east, west, north, south. Correct? Yes, so அப்போ north காட்டுதா? சரி, நான் இதை திருப்பி சுற்றி விட்டுறேன். Let us see whether it is settling down like that. Yes, correct? Okay, so this is nothing but the directive property of a magnet. Okay, இதில் நான் ஒரு விஷயம் மட்டும் உங்களுக்கு சொல்லிடுறேன். Actually, magnet பொறுத்த வரைக்கும் it attracts, right? Let us consider the directions alone. This is north, this is south, this is west, this is east. Yes, if I am suspending a magnet here, it turns like this, right? Yes or no? Correct? Turns na enna, idu north, idu south மாறுதா? Actually magnet என்ன பண்ணணும்? It should attract the opposite poles. Correct? ஆனால் எப்படி நார்த்தை நோக்கியே போகுது அது? It should repel தானே? How? Yes, we have two types of poles. One is normally called them as geometric poles. The other one is magnetic poles. Okay, so these are the two poles of Earth. We are only considering geometric poles, right? Magnetic poles in pathina, it is always opposite to these poles, and always it is inclined by an angle of around 21 degrees. Okay, so only illa simple solvom, north facing, south facing. Correct? Yes, actually நீங்கள் நார்த் ஃபேஸிங்கில் இருக்கீங்கன்னா யூ ஆர் இன் சவுத், சவுத் ஃபேஸிங்கில் இருக்கீங்கன்னா யூ ஆர் இன் நார்த். ஓகே, ஸோ we are only considering the geometric poles of Earth. We are not considering the magnetic poles of Earth, but these directions are derived from the magnetic poles, not from the geometric poles, because we don't know. எதை வச்சு நார்த் போல் சவுத் போல் கண்டுபிடிச்சிருப்பாங்க? ஒரு மேக்னெட்டை சஸ்பெண்ட் பண்ணதுக்கு அப்புறமா தான் அது நார்த்தா சவுத்தானே தெரியும். Imagine, no, those days when they were discovering the world. Yes, you know, Columbus and all traveled over the ships and he discovered many things and all, right? Yes, so எப்படி டிஸ்கவர் பண்ணியிருப்பாங்க? யூ ரிக்வயர் அ காம்பஸ், கரெக்ட்? எஸ். ஸோ ஃபார் டைரக்ஷன்ஸ், அப்போது நீங்கள் போகிற டைரக்ஷன் நார்த்து அப்படின்னா அது ஜாமெட்ரிக் நார்த். அந்த காம்பஸ் காட்டுறது ஜாமெட்ரிக் நார்த், ஆனால் ஆக்சுவலாக சவுத். அப்போ பேசிக்காக சன் ரைசஸ் இந்த ஈஸ்டே தப்பா? கரெக்டா? எஸ். ஸோ சயின்டிஃபிக்கலி we cannot say that. முதல்ல டெக்னிக்கலாக அது ரைஸே ஆகலை, நாம தான் சுற்றின்னு இருக்கோம். எஸ். ஸோ திஸ் இஸ் வாட் இஸ் சயின்ஸ், திஸ் இஸ் வாட் இஸ் ஃபிசிக்ஸ். பேசிக்காக அந்த மேக்னெட்டிக் போல்ஸுங்கிறதே வந்து we are dealing only with contradicting part of north and south of earth. ஓகே, இப்போ கூட நான் அதனால தான் சஸ்பெண்ட் பண்ணி காட்டினேன். நார்த்து காட்டுதில்ல, அப்போ அது நார்த்தா? சவுத்தாக இருந்தால் தானே அட்ராக்ட் ஆகணும். தட் இஸ் மேக்னெட்டிக் சவுத் which is geometrically north. Is that clear? ஜாமெட்ரிக்கல்னால் என்ன, நம்மளுக்காக நம்ம வச்சுக்கிட்டது, நம்ம கன்ஃபியூஸ் ஆகக்கூடாது. இப்போ நார்த்து காட்டுதுன்னா சவுத்துன்னு சொல்லிக்கணும் அப்படின்றது கன்ஃபியூஸ் ஆகுன்றதுக்காக நம்ம என்ன பண்ணிட்டோம், இந்த வேர்ல்டை வரையும் போதே நார்த்து சவுத்து வெஸ்ட் ஈஸ்ட்டு அக்கார்டிங் டு த மேக்னெட்ஸு, ரைட்? ஆனால் அக்கார்டிங் டு ஜாமெட்ரி இட் இஸ் ஆப்போசிட்டுன்ற மாதிரி கன்சிடர் பண்ணுறோம். அதனால தான் இது பேர் ஜாமெட்ரிக்கல் போல்ஸ், மேக்னெட்டிக் போல்ஸ் கிடையாது. இஸ் இட் கிளியர்? Right? That is why it has directive property.